Hello, welcome back to Algebra. We're continuing to work with parabolas in the context of conic sections. In this lesson, we're going to increase the problem complexity a bit. We're going to graduate from kind of the baby problems that we've done before into a little bit more advanced problem. What we're going to ask you to do is I'm going to give you an equation of a parabola of some sort, right? Sometimes it'll be more simple and sometimes you'll have to manipulate it a little bit, but I'm going to give you the equation of the parabola. And you're going to have to tell me the vertex of the parabola, the focus of the parabola, the directrix, which is that line that defines how the parabola is shaped, the axis of symmetry, and also to sketch each of these parabolas. So it's 5 things, really. It's a lot of different things, but it puts together everything that we've learned before. And before we get into it too much, I want to go back to what we've learned here. And we've kind of used this. I've left it on the board through all of these lessons. But I want to call to your attention before we get started with the problems that basically you always know if the parabola opens up or down if the square is on the x term. Think of the parabola y is equal to x squared. You know that thing opens up. If it's negative x squared, you know it opens down. When the square is on the x term, even if there's a shift here, you know it opens up or down. If the square is on the y term, you know it opens either left or right. It's going to depend on the sign of the value of a that's in front. So even if you don't have the equation of the parabola given to you in beautiful terms like this, even if it doesn't look so nice as that, if the square is in the x term, you know it opens up or down. If the square is in the y term, it opens left or right, and that's always true. The second thing is this little relation that the coefficient here, a, is equal to 1 over 4c, is going to pop up in all of these problems. It's going to be something we're going to use every time. C is just the distance between the focus and the vertex of the parabola. It's also the same distance between the vertex and the directrix. So we've talked about all this before, but we're going to use it. We're going to put everything together to solve these problems. So we're going to cover this stuff back up. We'll refer to it as we need as we go through here. What we're going to have to do is we're going to find the following things. We're going to find the vertex of the parabola. We're going to find the focus of the parabola. We're going to find the directrix. And we're going to find the axis of symmetry. That's what that is. And we're also going to graph. And when I say graph, I'm not talking about a beautiful graph with perfectly spaced everything. I'm talking about a general sketch. Once you know where the vertex is and you know where the focus is, yeah, to get the exact shape of the thing, you would have to find the exact points, but I don't care about exact points. I just want you to show me where that vertex is, show me where that focus is, and draw a general curve of the parabola. If you want to get exact, you can plug in values and get the exact numbers along the curve. So the first problem we have is very simple, but it's a very good one to start with because we can find these things pretty easily, and then the next problems after it will be a little more complex. So the first problem is the following equation of a parabola. Y is equal to 1/6 x squared. I think that you will all agree that this is a parabola because it's of the simplest one we have. Y is equal to some number x squared. Obviously, it follows the general form of this first relation here. It's just that there is no shift in the y direction and no shift in the x direction, but it's y equals some number times x squared. And because the square is on the x term, like I told you a minute ago, you all know that this parabola is going to open up, and that's because it's very simple. We've graphed this kind of thing many, many times before. So the first thing you need to do, even though you know what it looks like, is I want you to write it in kind of that standard form where, there's a shift in the vertex for the x direction and a shift in the y direction. In this case, there is no shift. There's nothing there. I mean, you can see that there's nothing there, but it's very instructive to go ahead and rewrite the thing. So you can write it like this. Y minus 0 is 1/6 x minus 0 quantity squared. Why am I writing it like this? Because notice I have y minus a number, 1/6, which is a, and then x minus a number squared, which is exactly the form of the parabolas that open upward. Y minus some shift, some number, then x minus some shift squared. I'm writing it like that because if I can put it into this form, then I can start reading information off of it. In this case, it's so simple, you already know there's no shift, but seeing that there's a 0 here and a 0 here is often very helpful. So because of putting it in this form, you can immediately tell that the vertex has a shift from the base location of basically no shift at all. So that means the vertex of this thing is at the origin, 0, 0. Also, because a is equal to 1/6, you know it opens up. And you also know that this 1/6, see the magnitude, the size of that number in front there,